useful. The great thing for us is it allows you to replicate the environment on your PC on any other computer very, very simply. So, yeah. Yeah. So, the reason that's a problem, I should expand things, right? If you have some sort of environment on your local PC, getting that to another computer 5 years ago was a little bit tricky, especially if you weren't a developer or an infrastructure engineer yourself. So now it's literally a matter of sending a YAML file and running a command will build any sort of environment that you want. So Python has virtual environments and whatever this is, like virtual environments for your actual hardware. So you can build, it's really good. So this is literally what's required to get a Python environment running on Linux. So I literally just whack this in a text file, send it to an AWS server somewhere, hit Docker build, and I have an environment that I can now run Python code in with all my requirements and whatever. So the great thing about this is it allows easy replication of your environment. So if I fire up a tiny little computer, tiny little server somewhere, build a Docker image on it, realize that it's performing crap, I basically just shut it down, send the file to a bigger one, and on I go. 5-10 years ago, it would take you so much of your time to do this sort of stuff, whereas now it's so easy, it just gives you a lot more time to do actual valuable work, which is working on your models, working on your theoreticals. So, cool. Docker Compose is just a step above. It's basically just a Python package that allows you to orchestrate multiple Docker containers. So, basically, if you want to run a host of services, this is effectively how you define them. So you have an individual Docker file and Docker Compose, and you can just list all your services here. So this is fantastic if you want to access infrastructure that or software that is typically a pain in the ass to install. So if you are not from a software development background and you've tried to install a database locally, you've tried to install MySQL locally or Redis or something, or a different operating system, or it's a pain in the ass. With Docker, you literally just go, all of the companies maintain their own official images. You just say, I want a Redis server here, and that's what you get, which is fantastic. Testing, this is obviously anyone from a software development background, but probably not so much for people who aren't. Testing is incredibly important, especially when building an algorithmic trading system. You need some sort of validation before you push changes to a complex system. So this is exactly the same in algorithmic trading sense. You don't really know what your system is going to do until you let it out in the wild. We had a really good example where we were trading in arbitrage on a couple of markets, and we thought, yeah, great, we'll write our trading scheme. If there's a 1% arbitrage, we'll trade 10 lots. There's a 2%, we'll trade 20 lots, etc., etc. We thought, yeah, this is fantastic. How could this possibly go wrong? And the system found a massive arbitrage between two exchanges and just went smack and locked up our entire account. We're like, well, shit, now what do? We've got to cross a massive spread to get out of this because the arb just stayed there for a day. We're like, this doesn't make any sense. So, not something you would necessarily find testing unless you had a good data set, but very important nonetheless. What you don't want is to make some breaking changes to your code and then have that implode, especially when you're going to be going to sleep while this thing runs. Yeah, cool. Visualization is really important. So I haven't really mentioned it, but we use Python for everything that we do. Python is a fantastic, as Thomas said before, fantastic candidate for quantitative trading. It's much easier or faster to develop in than some of the lower level languages, and the ecosystem is getting really, really mature. There's lots of exceptional machine learning, visualization, data processing and data engineering, libraries, and really like the sort of selling point for Python is that you can just import anything, and it is really the case. You can find a library for just about anything that you would possibly need. So when you're building a complex system, visualization and being able to aggregate your data in a way that you can you can actually visualize it is really, really important because you need to see what's happening, and if you've got 1,000 things going on, you need to be able to aggregate and to be able to deliver that to yourself in a way that you can make sense of it. So it also needs to come from inside your algorithm. You need to see what it sees. So often early on, when we were developing our system, we were putting logging outside of the core of our algorithm. We'll say, yeah, cool, we'll see what this is here, and we'll have a little visualization of it. But you need to see exactly what it's seeing, because that's the only way you're going to be able to understand what it's doing. Yeah, so a heap of our bugs were found literally just looking at graphs, like this one, not that you can see, but basically we couldn't figure out what was going on because we had a bunch of different trading systems running at once, and we just threw up a graph of our Theo and we just found it fell off a cliff at this point. So we at least knew where to start, whereas we put up some recent data and it's like, oh, this looks all right, but really, back here we'd gone and entered into this massive position and we're like, well, this looks kind of okay here, but yeah, being able to visualize a lot of this stuff made it really, really easy to debug what was going on. Lots of options available in Python. We typically use bokeh because it has really nice real-time plotting, but there are lots of options. This is an unrelated photo from Luigi. This is Luigi is like a data engineering, data processing, data pipeline library, and it gives you fantastic oversight of what is happening in your pipeline. So we use this as well for processing data, and again, if you have a really extensive or complex data pipeline, Luigi makes it really easy to see where exactly something is breaking. Cool. So, any questions? That was kind of fast, but I wanted to sort of get into this. Any questions so far?
Can you just reiterate what you mean by Theo in this case?
Yep.
So I'm thinking of options Theo the whole time. It's nothing to do with
Yeah, Theo is, it's kind of an option. The Theo is anything that you're going to use to trade against, basically. So you're going to if you're going to trade some sort of financial instrument, you're going to come with some sort of price for it. It might be a price relative to something else. It might be a price that's completely unrelated to...
Are you trading a reversion to that price?
Not necessarily. You might even be trading like a momentum thing. I might use the current price of the stock plus some sort of number of tweets about the company to come up with my Theo. As soon as I see lots of tweets, I just jack my Theo up and I buy. So it's basically the Theo, I would say, is any sort of output of any model that you have and then feeds into some sort of trading system. So yeah, you are looking for it to revert or to follow your Theo, basically. One or the other. Any other questions? Cool. So, algo trading in Bitcoin. Does anyone not know what Bitcoin and or cryptocurrencies are? Cool. Is anyone, everybody familiar with the state of like the market structure of Bitcoin and how it all sort of operates? So, Bitcoin is obviously cryptocurrency that you can send to any sort of address. So, lots of sort of local exchanges have popped up in the Bitcoin space. So we've got a couple here in Australia. My particular example uses BTC markets, but it's a very, as Bitcoin is decentralized, the exchanges and the market structure of Bitcoin itself are also very decentralized. There are hundreds of exchanges all over the world, and you can pretty much move your money in and out of them using Bitcoin as you see freely. So it is a fairly good candidate for proprietary trading or quantitative trading. So I'm now going to go through the process of putting what I've just spoken about into an algo trader that can basically market make on a Bitcoin exchange, and then this can then be expanded as you see fit. So we're going to use the market making example because it's quite simple. Does anyone not know what market making is? Cool. So market making is what is Optima's bread and butter. So it's basically we are providing quotes to the market and we are trying to scalp the difference between the bid and the ask. So when you see a stock price, what you're actually seeing is a bid and an offer. So a price at which someone is willing to buy it and a price at which someone is willing to sell it. Now, in a lot of cases that might just be two random market participants, in some cases that may be two random market participants, but in a lot of cases that will be a dedicated market maker. So most advanced exchanges in the world, probably all, and most even some of the lower tiered exchanges would have market makers, and basically they are paid in some way, shape or form to provide liquidity to that exchange. So the whole premise is basically you're putting quotes to the market. If someone buys and sells from you, in a split second, you make the scalp between the bid and the ask price. Where you lose money is basically where someone buys from you and they know something that you don't, and the market moves against you. So the balance is always between trying to quote wide enough that you cover your risk if the markets move, but also tight enough that you get lots of what we would call two-way, which is a buy and a sell, and essentially a riskless scalp. So it's quite easy. Basically, the way that we market make is we generate a Theo some way, and then we would place a bid and an ask around that Theo, and that's basically. So we're gonna try and replicate a simple market making model on BTC markets because they're an Aussie exchange. They accept AUD payments from your credit card, and it's also not one of the bigger exchanges, so it's not super liquid. And the spreads are quite wide, so it moves at a slow pace. So it's a good candidate for starting out and having a crack at building a market making algorithm, because you're not going to get run over basically, or you're unlikely to get run over. Yep. So from a just code structure point of view, we're going to have a single data source. You can't even see that. We're going to have a data source up here, BTC markets, and so we're going to receive market data from them in the form of order updates, trade updates, and we're going to have our algorithmic trading code down here, and we're going to send our orders into this market source. So we're going to have some code that sits at one end and basically sends down market data, and then also receives any orders that our algorithmic trading code wants to send. And in between, we're going to have 0 and Q as our inter-process communication. So it's just going to be a system that we send data down, basically. This is an example that is highly likely to make money in the long run. In the short run. Yep. So just a little bit more about the Bitcoin exchanges. Typically, they're pretty good from a developer point of view. In comparison to like the world's largest broker, Interactive Brokers, all of the Bitcoin exchanges use a REST API, kind of, and a lot of them actually use WebSockets, which is fantastic because rather than polling once every second or whatever, you just get a stream of data, which is fantastic from a reaction point of view. If you're operating in a fast-moving market and you can only request the state of that market once every second, that's ludicrous. So, but most of them are quite good. Unfortunately, BTC Markets uses a polling REST API, which is okay because it's slow moving and it's a good sort of start without having to deal with a lot of information. But there are much more advanced exchanges who have WebSockets and just feed you data, which is fantastic. Interactive Brokers, which I'm sure everyone knows about, one of the largest brokers in the world, their Python API sucks. So I have nothing for this whatsoever. But if you want to trade Bitcoin, like happy days, like most of the exchanges are pretty good. Yeah, from a trading point of view, some of the exchange internals and order book implementations are a bit strange, but yeah, otherwise fine. So, can you see that? Can everyone? Oh, God. Is that any better?
Yeah.
Cool. Okay, so this is pretty simple. So the first step, basically, to being able to get market data is creating a wrapper for the API you want to get. Most of the Bitcoin exchanges have Python APIs. BTC markets have heinously documented code, but thankfully it's reasonably straightforward to get data. It's just a REST API. It should be reasonably straightforward. So I'll throw this up on my GitHub repo and open source it when this is over. But basically, all I want to show here is we're just wrapping a bunch of endpoints that we can connect to. So we need to have this wrapped up in a class somewhere that we can access it. And they use some stupid HTTP crap that I don't understand, but it's fine. Yeah, so depending on the implementation, we typically want to wrap this in some sort of, so we have a Python wrapper for the API. We typically want to go a step further and wrap that in some sort of convenience class that we can interact with a little bit better. So we're effectively going to create a long-running process that is going to feed us market data and that we can interact with our trading algorithm. I quite like the microservices sort of approach. A bunch of developers here all, I don't know, people love it or hate it or whatever. I like sort of having microservices because it makes things manageable and readable. I can pass some code to someone and say, this just does this small little job, and they can sort of understand it. So we've got our API that defines basically the endpoints that we can hit, so how we can get market data, how we can process insert trades and delete trades. We're going to wrap that in another little process that basically feeds our algorithmic trader market data, and then also listens for incoming orders that we might want to send or delete. So just as an example, this is what the wrapper might look like. So we grab our API, we need some sort of publish and subscription model, so we're going to use 0MQ here. We're basically just going to publish market updates as they come through, and then we effectively just need some something that listens to some sort of channel where we can insert orders, and then we just interact with the API here. And then in addition to this, we have some looping process that literally just says, check if we've tried to insert an order, check if we've tried to delete an order. If not, send down some market data. And also this kind of handles the throttling and a few other things. It just abstracts it away from your market making or your algorithmic code that should be fairly pure. You don't really want to mix it all together, because you might write a really good algorithm that does market making or whatever, and you don't want to be riddled with code that is specific to this market, because if you want to go and apply it to another couple of exchanges, you don't have to remove all of that. You basically just want to keep things simple. So our market making class might look something like this. We're going to need some sort of configuration. We're going to need to know how wide we're going to quote, what sort of level, what sort of size we're going to quote, how many levels we want to quote. So we might just want to put in one order on the bid and the ask. We may want to actually layer the book in case someone pays through. So a pay through is where the offers might be $10, $11, $12, and someone says, oh cool, I just want to pay $15, they just pay through the entire book. So we may want to actually layer multiple levels in our market making code to take advantage of, if someone pays through the book, you get filled at all those good levels. Some sort of retreat, so just sort of a little bit more on market making theory. If someone trades against you, so say I'm a market maker and I've got a bid and an offer in the market. If someone lifts my offer, so they buy my offer from me, what could that signal to me? The market's going to move? Yeah, why do you think it's going to move?